Mercury is one of the most unexplored planets in our solar system, but that's not because it's the most boring or anything like that. It's quite the opposite, actually. Mercury, being the closest planet to the Sun, our star, has so many confusing mysteries about it. Mercury has a diameter of 4,879 kilometers, making it about one-third the size of the Earth. Yet, it also has the second highest density in our solar system, at about 5.427 grams per centimeters cubed. How can this be?
You dense motherfucker!
Mercury is essentially one big ball of metal surrounded by a small outer layer of rock. At the surface, Mercury has a plethora of crater impacts suggesting a violent past. Using a spectroscope, we have identified that this small rocky layer is rich in minerals like potassium and sulfur. These elements typically evaporate at relatively low temperatures though, so how does Mercury, the planet closest to the Sun, have this secret hidden stash of minerals? Like I said, Mercury has signs of a rough, chaotic history, and one of the theories we have is that Mercury actually formed further away from the Sun than it is right now. The idea is that Mercury, as a young planetary embryo, brushed past and collided with something, possibly another planetary embryo, which ripped off most of the planet's crust and mantle. The remaining planetary core was just flung into space towards the Sun and then finally trapped into its famous weird orbit. Mercury's orbit has caused so much confusion over the years. Mercury has the most eccentric orbit in the solar system, along with the slightest axial tilt at 0.027 degrees. Because of this odd orbit, Mercury can be between 46 million to 70 million kilometers away from the Sun, depending on where it is in its orbit. Making things even more confusing, Mercury also rotates faster than it orbits. It has a 3-2 spin per orbit resonance, meaning that every 3 times the planet spins on its axis, it has orbited the Sun twice. This means that what we call a solar day on Mercury, from one sunrise to the next sunrise, is equivalent to 2 years or full orbits around the Sun. Mercury also has an extreme fluctuation in surface temperatures too, with a hot side facing the Sun, reaching temperatures as high as 426 degrees Celsius, 800 degrees Fahrenheit.
What kind of place is this?
On the other side, facing away from the Sun, temperatures can drop down to negative 173 degrees Celsius, negative 279 degrees Fahrenheit.
I'm so cold that I'm shivering.
This crazy temperature difference is because Mercury realistically is just too small for gravity to retain any real significant atmosphere, which would in turn retain some of that lost heat. Speaking of lack of an atmosphere and heat retention, we've found that craters in the north and southern pole regions of Mercury have frozen water ice, which was discovered with NASA's MESSENGER probe. Mercury to this day remains to be one of the more mysterious planets in our solar system, because of its strange orbit, insanely high and low temperatures, and the fact that getting into the planet's orbit without just speeding by is extremely difficult. It actually takes more energy for a spacecraft to reach Mercury than it would to reach Pluto. Missions trying to enter orbit there typically fly past Earth, Venus, and Mercury itself, using gravitational nudges to adjust their trajectories. Because of multiple oddities and difficulties with Mercury, we've only sent 3 total missions, 2 of them being past retired programs. The third, however, is a new program. Bepi Colombo is a project composed of 2 different spacecraft launched in 2018 by European and Japanese astronomers. It has completed 3 flybys of Mercury so far, needing 3 more until it is expected to finally enter Mercury's orbit late in the year 2025. The goal of this mission is to study the frozen water ice at Mercury's north and south poles, as well as the planet's abnormally large core and magnetic field. This will ultimately help us learn more about how Mercury was formed